Hello friends, welcome back to my YouTube channel. Myself Vishnujay, currently studying in Sri Venkateswara College of Engineering. Course title is Mathematics 2 for CSE. My course topic is Introduction to Vector Calculus. Introduction to Vector Calculus. Vector calculus is a branch of mathematics that deals with vector fields and their derivatives. It extends concepts of calculus to high dimension, typically in 2D and 3D spaces. It's essential in physical engineering and many other fields where quantities have both magnitude and direction. Key topics included vector fields, diagrams, curl, line integral, surface integral, and the theorem of Gauss, Green, and Stokes. It likely the bridge between calculus and geometry, offering powerful tools to analyze and solve problems involving vectors and vector fields. Vectors and their properties. Vectors are mathematically entities with both magnitude and direction, unlikely scalars which have only magnitude. Vectors can be represented visually as directed line segments with an origin and a terminus point. Key factors properties include addition, subtraction, scalar multiplication, and the ability to resolve a vector into components. Vector operations, addition, subtraction, and scalar multiplication. Vector addition. Vectors can be added by placing them head to tail. The resulting vector points from the tail of the first vector to the head of the last vector. Vector subtraction. Subtracting a vector is the same as adding the negative of that vector. The resulting vector points from the head of the subtended to the head of the minended. Scalar multiplication. Multiplying a vector by a scalar, a real number, results in a vector with the same direction but a different magnitude. The vector is stretched or compressed. Geometric interpretation. These vectors operations have a clear geometric interpretation, making them powerful tools for working with vectors in 2D and 3D space. Dot product and its application. The dot product, also known as the scalar product, is a fundamental operation in vector calculus. It captures the degree of alignment between two vectors, providing a measure of their similarity or dissimilarity. The dot product has numerous applications in physics, engineering, and mathematics. Including calculating work projection one vector onto another and determining the angle between two vectors. Cross product and its application. The cross product is a binary operation that takes two vectors and produce a third vector perpendicular to the other two. This operation has many important applications in physics and mathematics, including calculating torque, finding surface normals, and describing magnet fields. The cross product is particularly useful for determining the direction of a force or flow, as the resulting vector is always perpendicular to the original two. Gradient, divergence, and curl. Gradient. The gradient of a scalar field is a vector field that points the direction of the greatest rate of change of the scalar field. Divergence. The divergence of a vector field is a scalar field that describes the density of the outward flux of a vector field from an influential volume around a given point. Curl. The curl of a vector field is a scalar field that describes the influential rotational of a field around a given point. It measures the tendency of the field to spin. Line integrals and their properties. Definition. A line integral is the way to integrate a scalar or vector field along a specific path or curve in space. Interpretation. Line integral represent the accumulation of a quantity such as work or flux along a path. They provide a way to measure properties that depend on the path taken. Applications. Line integrals have many applications in physics and engineering, such as calculating the work done by the force field, the charge flux through a wire, and the circulation of a vector field. Advantages of vector calculus. Geometric institution. Vector calculus allow for a more intuitive geometric understanding of complex mathematical concepts compared to traditional scalar calculus. Versatility. The vector-based approach can be applied to a wide range of fields including physics, engineering, and computer graphics, making it a high versatile tool. Efficiency. Vector calculus provides a more conscious and efficient way to express and manipulate multidimensional relationships, leading to similar and more elegant solutions. Disadvantages of vector calculus. Steeper learning curve. The conceptual and mathematical sophistication of vector calculus can make it more challenging to learn compared to traditional scalar calculus. Increased complexity. The higher dimensional nature of vector calculus can lead to more complex calculation and problem solving, especially for those new to the subject. Limited applicability. While versatile, vector calculus may not be the most appropriate tool for certain problems that can be efficiently solved using scalar calculus. Thank you so much for watching my video. Please like, share and subscribe the video. Thank you.